Hi guys, today I am going to talk about matter and change with you. What you will need are your notes, highlighter, colorful pens or pencils to write with. Okay, so let's get started and you can follow along with your notes. So matter. All objects are made up of matter. Matter has mass and it occupies volume. Forces act upon matter. And the basic unit of matter, at least in chemistry, is atom. The quantity of matter in an object is its mass. So this is the quantity unit that we use, and the symbol is for mass M that we use. And mass of an object is constant, no matter where it is, because the amount of matter or the amount of atoms is constant. So right here. And this is true because no matter where we go, whether we go on this planet, the moon, Jupiter, the amount of mass is the same. So the mass doesn't change because mass, when we talk about mass, we are talking about atoms. That doesn't change when we're talking about making up matter. You might get this word confused with the word weight, and when we talk about weight, we are talking about gravitational pull on that mass. So my weight here on planet Earth could be different from my weight on the moon or on Jupiter, but not my mass, because the number of atoms that make me up on this planet will be the exact same as well as on the moon and Jupiter. But in chemistry, we will be using both mass and weight synonymously, so we will be interchanging the word mass and weight. Okay, go on to the next page. So you should have this chart right in front of you. Now, these are skills that really you will be using all year round. So this is basically everything that I'm going to talk about in chemistry. So this is all your skill. Okay? So this is everything. Okay, so let's get started. So when we talk about matter right here, keep in mind that matter has both mass as well as volume. And it's if you have matter and it cannot be separated by physical means. So if it cannot be separated by physical means, then it is called a pure substance. However, if something can, and that's a really big deal, if something can be separated by a physical mean, then it is called a mixture. Okay? So what do you mean by physical means? What I mean by physical means is that we can sort it out, pick through it. We can use a magnet to separate the metal from it. We can filter the substance. We can use crystallization and form crystals and then separate it that way. And of course we also have density. And of course there are other ways to separate it by physical means, but these are just a couple. So if matter cannot be separated by physical means, then we say that that matter is actually a pure substance. Okay? And that pure substance can be two things. It could either be a compound or an element. If that pure substance can be broken down by chemical means, and when I say chemical means, I mean, can I burn it? How about, does it rot? Does it rust? Does it combust? Corrode? These are all examples, and there's so many more. So I'm just going to put ... So many more that if it can somehow change where you now have, it can be broken down through a chemical means, then we say that it is a compound. Okay? And keep in mind that a compound is made up of two or more different elements. Okay? Two or more different elements. And some examples of a compound is glucose. Now you can't tell that this glucose is a compound because it's just a word. But if you knew the chemical formula for it, then you would know right here, C6H12O6, now you know that it is a compound because it is made up of 1, 2, 3 different elements. Water, as you know, is H2O. Carbon dioxide, you know, is CO2. So each one of these is 1, 2 different elements, 1, 2 different elements. So it's a compound. Now let's go back to pure substances. And if this pure substance cannot be broken down by chemical means, if it cannot, then it is an element. Okay? And these elements are pretty easy because you have a something called the periodic table that actually gives you a list of the elements. So you have a periodic table. And here are the list of the, just a couple of the elements. There are, of course, so many more on your periodic table. Okay, so let's go back to the very top where it says matter. And if you have matter where you can physically separate it by some kind of physical mean, one of these or so many other ways that you can do it. If you can, then we say it is a mixture. So what exactly is a mixture? Mixture is elements and or compounds that are physically mixed. Okay? And there are two types of mixtures. One mixture is non-uniform composition. And when I say that it is non-uniform composition, I mean that it has a different composition each time you take a sample of it. So let's say that I like Skittles. So I take a bag of Skittles, and if I open up a bag of Skittles, the colors could be very different from the colors and the flavors of another Skittles bag that I open. So every single time I open up a bag of Skittles, it's a different composition every single time. And when it is different, we say that the substance is heterogeneous. So the word hetero means different. Okay? So we say it is heterogeneous. So examples of it would be granite, pickle, relish, noodle soup. I'm going to put Skittles here. Okay? So on the other hand, you have mixture right here. If a mixture is uniformly mixed, or it has a uniform composition, meaning that it is evenly mixed. Okay? So an example of a homogeneous mixture would be something like steel. So if you have steel, and if you cut off a piece of that steel, and you have steel from somewhere else, and you cut off a piece, they are supposed to be the exact same composition. Both samples of the steel will have equal amounts of all the different metals that we have. So steel is considered to be a homogeneous mixture. Now this is pronounced homogeneous. You can also say homogeneous, but usually we say homogeneous, and the word homo means same. Okay? And some examples are seawater, air, bronze, brass, and then also we can say it is steel. Okay, so that's a really good example of it. The idea is that if we take two different samples of a substance and we examine them, they should have the same composition. Now another word for homogeneous is actually solution. So whenever we say something is a solution, we are saying that it is homogeneous, where it's evenly mixed throughout. Okay? Now, if we move on, we're under pure substances. Remember under pure substances that we have compounds and elements. So going further, compounds, on the other hand, elements, are the simplest pure substance that we have. Compounds, on the other hand, compounds are composed of two or more different elements that are chemically bonded. And they have different properties from the elements making it up, and they do have a set formula. Okay, so that's really important that they do have a set formula. So if you look at this picture right here, okay, if you look at this picture, this is just a set of pictograms. And the idea of a pictogram always is that you should be able to look at it and you should be able to tell many things about what's happening. Since these are pictograms of elements, compounds, and mixtures, we're talking about at the submolecular level, you should be able to look at it and tell me what is going on. So if you look at this first picture, this is a bunch of single atoms that are present, and they all are the exact same color. And you should be able to see the color if you look at the second one. There is a stark difference between this one and this one, so they happen to be different colors. Okay, but the first one has all of the elements are the exact same color, so we would actually say that this is an element because they are the exact color. Right here, this is an example of also an element. This just happens to be called molecules. Actually, there are 2 atoms that are connected to each other. Clearly, they are the same element. So a lot of the times when molecules are just 2 at a time, we like to say that they are diatomic. Okay, so when we talk about diatomic, I'm going to go back over here to molecules. We say that there are 2 atoms, and we say it is diatomic. And when the acronym for diatomic is really HOF, Brinkel, and it is H is for hydrogen, and it is 2 atoms of hydrogen, so it looks like this. Oxygen is also O2. Fluorine is F2. Bromine is Br2. Iodine is I2. Nitrogen is N2. And then chlorine is Cl2. Together you have 1, 2, 3, 4, 5, 6, 7. So you really have 7 diatomics in here. Okay? So that's what these molecules are when they're bonded together. I'm not saying that all molecules are diatomics. I'm just saying the molecules that are together are sometimes called diatomic. In this case, they're the same atoms that are put together, so they're the same elements. The elements come in 2s then, so these would be diatomics. If you look at the next one, skip to compounds. Where is this compounds? And if you look at this, this is every single compound in here is the exact same. Keep in mind that a compound, I'm going to draw a picture of this one, this happens to look like this. Okay, where it is 2 different colors. I've got 2 different colors here, so if I want to translate that, this would be oxygen that is bonded to a hydrogen and another hydrogen. So a compound is 2 or more different elements that are bonded together, chemically bonded together. So we have hydrogen and oxygen that are bonded. So this is a bunch of compounds that are put together. Okay, they're the exact same compound in here. So we would say that this is just pure compounds. So we have elements and compounds. Now going to mixtures, mixtures will be a combination of a lot of things. So in this case, if we look at the very first picture, you've got not only element number 1 right here, but you have a second type of element, and this is element number 2 right there. So you've got element 1 and element 2 right here. And these elements, it's a mixture. They are combined in here together where different stuff is inside. Now if we look at the second picture, again this is another example of a mixture because you do have an element. Once again, it's a single atom, so it's an element. So I'm going to write here element number 1. And then this right here, this is also an element, but more specifically, remember, it's a diatomic, so that's a little different. So this right here is a mixture of element and diatomic that are mixed together. Okay? Now if we look at the third picture, the third picture is you've got a diatomic, which is an element, remember? Diatomic number 1, and then you have diatomic number 2. So this is a mixture of two different elements, okay, which are two different molecules or diatomic. So both of these would be considered your elements, but they're different types of elements, okay? And your fourth picture right here, again, it's a mixture. You can see it where you have a compound. And my abbreviation for a compound is CMPD. And then you have here your molecule or your element, which is your diatomic. So, molecule. So you have a combination of not only compounds but of elements in the fourth picture. So this is again a mixture. Okay? So reading these pictograms is going to be very important for you because you can tell a lot about a picture, a lot about a substance by just looking at it. Okay? So if you move on to the next page where it says mixtures, let's look at this, and we say mixtures are substances which are formed when elements or compounds are mixed, are physically mixed together, but the mixtures do not have a definite formula, and that the mixtures have properties which are similar to the properties of its constituent substances, or the mixture has properties based on the stuff that it is made up of. So it's going to have those properties. And then mixtures, of course, mixtures can be heterogeneous. Remember, heterogeneous where they do not mix evenly, so they do not have a uniform composition, or they could be homogeneous where they do have a uniform composition. Okay, so that's where the difference comes in between the two. Okay, so your key words here are homogeneous, they do, and heterogeneous, they don't. Okay, so if you move further up here now to the next one, next picture, if you look at it, this right here, just look at these two pictures, you can clearly tell that they are different. First of all, if we're looking at these two pictures, you can look at this picture and say, yeah, there's two kinds of stuff in here. There's this, number 1, and there's number 2. And you don't have to have 2. You can have 3, 4, 5, 6 different stuff in here. It doesn't make a difference how many you have. And notice that they are, through this container right here, they're just evenly mixed throughout. So they're not only clumped up in one area, but they're evenly mixed throughout. And it's not just you find this particular compound in one area separate from everything else, but it is evenly mixed throughout. So we will say that this is homogeneous. Okay, keep in mind homo means the same, so that they are homogeneous. And over here, really, we would say that this is your salt, NaCl, and this is your water, H2O. Okay. Over here, when we are looking at this picture, now you notice that there's something going on. There's a separation. At the bottom, you've got the salt here, and at the top, you've got this water that is over here. So clearly, something, they are completely separated from each other in this case. So you've got your salt that is over here and your water that is right there. So there is a separation. Even though it's a mixture, it's not evenly distributed. So we would say that this is a heterogeneous mixture. Okay. Now, real quick at the bottom of your page, go ahead and draw the three phases of matter. So you have three phases. Okay. First one is a solid, as you know. And I'm just going to draw my box. Then you have your liquid. Okay. And then you have your gas. And sometimes I'm going to redraw your liquid. And then you have your gas. Okay, so if you see this, you're looking at your solid. It's very compact, right? It's compact. There's hardly any space. It really just, it's compact. This is now, it takes the shape of its container, and there is some space in between. This one has lots of space in between. And yes, it is also, it's really filling up the entire container. So keeping these pictures in mind, if you look over here, going back to this original picture, now what does this look like to you when you look at it? So when you look at this, you know that it's a homogeneous mixture, but is everything really compact like a solid? Or is everything just really taking the shape of its container and there's some spaces between? Or is there a lot of space in here? Well, there's a lot of space in here. So we would actually call this gas. This would be a type of a gas right here. On the other hand, right here, we would say that this, if you're looking at this, of course it is separated, but also know how it is separated. Look at how this bottom layer is actually, how it's around one another. There is space between, but sometimes there isn't space. So this is here at the bottom of the container. So we would say that this is your liquid. And then notice that this water that's on top is just really trying to spread out right here, trying to shape of the container, take the shape, so we would say that this is gas. Okay? So that's what we mean by states of matter. You can look at these pictograms and you can tell how it looks. You can talk about the state of matter for this. Okay? Now, real quick, go to where it says solids, liquids, and gases, your phases, and let's talk about it. Solids have a definite shape and volume, we know that, and more in particular, their particles are compact. So I'm going to put stars next to it because that's like super important. They are compact. That's what I really want to know. Okay. Liquids, on the other hand, as you know, you probably learned, they have no definite shape, but they do have a definite volume. Okay. But what's really important, that it flows and takes the shape of the container. That's huge, that it takes the shape of its container. Okay. Not only does it take the shape of its container, but the space between the particles and between the solid, it has space between its particles. Okay. So this is the most important, space between its particles, and I'm going to highlight it or underline it, circle it, but definitely put my stars there because there is space between the particles. And then we have gas at the end, the third phase or state of matter that we have. And this state of matter is that there is no definite volume. So when there is no definite volume, we say simply that it just fills its container. And keep in mind that these three are states of matter. Okay, these are the states of matter. Going back to gases, gases are particles. Particles are separated the most from each other. So in a gas, you'll see the most separation, like here. So you've got the most separation here. Liquids, there is some space in between that's filling up the container. It's beginning to take the shape of the container, but this is definitely very compact. Okay, so if we go back, at the bottom, I want to make this correction. It's not the phases, but it's the three states of matter. Okay, three states of matter. And then finally we get to a point where we're talking about metals, nonmetals, and metalloids. You have metals that are right here with the exception of hydrogen. So all of your metals that you have are right here. And metals are usually good conductors of heat and electricity. They're also malleable. That means you can hammer it down. You can press it and you can flatten it out. Ductile means that it is that you can make it into a thin wire, and it is very shiny. Okay, it is shiny. So you've got aluminum. Aluminum, remember, you can hammer, you can flatten aluminum out. It is malleable. You can also take aluminum and you can make it into a very thin wire, and it's definitely shiny. So this is all of the metals, with the exception where hydrogen right here is a part of your nonmetals. Okay, so now let's talk about your nonmetals. Your nonmetals are the exact opposite. They are poor conductors of heat and electricity, and they are brittle when they're solid, so they just break apart. Okay, and then you've got your metalloids. Metalloids, of course, they're moderately good conductors of heat and electricity, and they're moderately brittle. Okay, and they're moderately good conductors of heat and electricity, I would say, under certain conditions. Okay, so my examples of a metal would be iron. Of a nonmetal, an example would be something like sulfur. In my nonmetals, well, there's a staircase right here on the periodic table. So you may want to draw that. And so boron would be an example of it. Then you've got silicon, germanium, arsenic, antimony, Pe, and At. Those are the different metals we have. Together, we have a total of 7 metalloids. Okay, 7 metalloids. Okay. So those are the 7 that we have. Okay, so this concludes my lecture on matter change, pure substances, mixtures, metals, metalloids, nonmetals, and the phases. Okay, bye guys.